So today we're going to be going over logic gates explained with examples. So the first gate we're going to go over is the AND gate. So the way that a logic gate works is we'll have an n amount of inputs, but for this we'll just have inputs A and B. So when we're working with logic gates, we can only use binary since it's going to be like computers. So we can either have a 1 or a 0. So the options for A are 1 and 0. And for B, it is also 1 and 0. However, we have to find all the combinations between the 1s and 0s. So for example, we could have 1 and 1, 0 and 1, 1 and 0, and 0 and 0, which are all the different combinations between our inputs of A and B. So what the AND gate says is the AND gate will say if we have A equaling to 1 and B equaling to 1, then our input will be 1. However, since we have 1 and 0, and it's not going to be 1 and 1, it's 0 and 1, this means that it's going to be a 0 because they're not the same. And the same thing here, we have 1 and 0. And since they're not the same, this means our output is going to be a 0. And finally, we have our AND for 0 and 0, which will also be 0. Because even though they're the same, we're still having a 0 and 0. So for our AND gate, the only way that our output is 1 is if A and B are equal to 1. But next up, we have the OR gate. So again, we'll have our A and B with 1, 1, 0, 1, 1, 0, and 0, 0. The difference with the OR gate is as long as one of the values of A and B is 1, then our answer will be 1. So we have A and B both equaling to 1. So since at least one of them is 1, we'll have an output of 1. Now for here we have 0 and 1. And since at least one of them is 1, we'll have an output of 1. Same thing here, we have 1 and 0, which gives us an output of 1. However, for 0 and 0, since neither of them are 1, our output will be 0. And our final one for the first page is the NOT gate. So the NOT gate only really works with one input. So if we have our input A, which is either 1 or 0. When we put it through the NOT gate, the only thing that it does is it will switch what our input is. So since we start with the input of 1, it will just become 0, and when we have an input of 0, it will become 1. So our next gate is the NAND gate, which is the opposite of the AND gate. So we'll have our 1, 1, 0, 1, 1, 0, and 0, 0. The difference with the NAND gate is if we have 1 and 1 for our A and B, this will become a 0. And whenever the numbers are not both 1 and 1, it will become a 1. So it is the complete opposite of our AND gate. And now next up we have the XOR gate, the XOR gate. So we'll have our inputs of A and B with again the same values 1, 1, 0, 1, 1, 0, and 0, 0. So the way the XOR gate works is we will take our 1 and 1 and we'll add them together. And since when we add them together, because we're in binary, so 1 plus 1 is going to be modulo 1, this will become 2, which will make this equal to 0. So our 1 plus 1 will become a 0. However, in binary, again, we'll have 0, 0, and 1. And if we add them together, this will be equal to 1. Same with this, 1 and 0, add them together, this will be equal to 1. And finally, 0 and 0, add them together, is still going to be 0. And now, our final one is the XNOR gate, which if we have our A and B, the way this one works is, again, the complete opposite of the XOR gate. So we'll have our 1, 1, 0, 1, 1, 0, and 0, 0. And this will only be equal to 1 when, if we add them together, it equals to 0. So again, 1 plus 1 normally gives us 0, but here it'll give us 1. And this one, 0 and 1, would normally give us 1, but since it's the reverse, it'll be 0. And so forth for the rest of them. So now finally we have our implied gate, which is this arrow right here. So if we have our inputs A and B of our 1, 1, 0, 1, 1, 0, and 0, 0, we'll output 0 only if A is 1 and B is 0. And if A is 0 or B is 1, the output will be 1. So when we have our A and B here, when it's 1 and 1, our implied gate will be equal to 1. However, and for 0 to 1, it will also be equal to 1. But when we have 1 implied on 0, this will be equal to 0. And when we have 0 implied on 0, it will be equal to 1. So now we have our question, which has our A and B values as 0, 0, 1, 0, 0, 1, and 1, 1. And here we want to find our A naught implied on B naught. So A naught will become 1, and our B naught will also change to 1. So now it's 1 implied on 1, which is still 1. Now this will be our 1 and 0, but because of knots, it'll become 0 and implied on 1, which if you remember from applied is still 1. But now this one will become 1 and 0, which one implied will become 0. And then this one will be 0 and 0, which implied will become 1, because it will just change to 0 and 0, and from our chart before, we know that is 1. So now we want to find whenever our A naught implied on B naught is also and A. So we have multiple steps here. So what we need to do here is we need to forget about the beginning of our chart. We need to look at our A naught implied B naught and check it with our A value. So first up, we have 0 and 1, which since they're not the same, this will become 0. But now this will be 1 and 1, which will become 1. And now this one is 0 and 0, which will be 0. And finally 1 and 1, which will become 1. So now finally we have our A and B, and we need to do this in 3 different steps to get our final answer. So we have A and B, A naught, B naught, and then finally A and B, or A naught, or B naught. So the first one we're going to do is our A and B, which if we know they're not both 1, it will be equal to 0. So this will be 0, 0, 0, and 1. Now our A naught is easy since it will just be the inverse of whatever our A's are. So this will be 1, 0, 1, 0. And same thing with our B naught, this will be 1, 1, 0, 0. So now finally we need to check to see, and since this is OR, we need to check if either A and B, A naught or B naught is equal to 1, and then our output will be equal to 1. So since in our first row we have A naught and B naught equaling to 1, our answer will be 1. In our second row we have B naught equaling to 1, so our answer will be 1. In our third row we have A naught equaling to 1, so it will be 1. And finally in our fourth row we have A and B equaling to 1. So our answer for the logic gate is going to be 1, 1, 1, and 1.